at the very top of our notes, I am going to put what factored form is. So it just looks like what you just saw. So it would be y equals, there's going to be some a out in front, the same a that we've been dealing with for standard form and vertex form. But then you're going to have x minus some number. I'm just going to call it p today. Okay, but there's going to be a number there. And then x minus q. And what factored form is going to give us is, once again, x are liars, okay? The x-intercepts of this would be p comma 0 and q comma 0. So that's what factored form is, but today we're just going to review what if you have something that's not already factored, okay? Sometimes I'll just give it to you in factored form. That's been pretty easy to spot, and we'll talk about that tomorrow. But what if I don't? We should review some of the things with factoring. So that's what we're going to spend our time doing. And I'm really sad that that Corey's not here, because I was going to use him, because when we do box method, who remembers box method? He was anti-box method, which is fine. But I was going to talk about it, and now he's gone. He'll hear it when he listens to the video. We won't tell him. It'll be a surprise. All right, so there's a couple kinds of factoring that we're going to deal with. One, probably the easiest type, is common factoring. Okay, so I'm just going to throw lots of examples at you. So what I mean by common factoring is you might see something like this: 7x squared plus 9x. Okay, so common factoring means that you're going to take a GCF, greatest common factor, out of both terms. All right, see if you and your partner can figure out what is the highest thing that goes into both of those terms. Oh, nobody knows. What is it? Is it a number? Is it a variable? Is it both? Kimberly, what do you guys think? You want to pass? Gabe, what do you think? What's the highest thing that goes into both? It's just an x, yeah. So sometimes it's just an x, sometimes it's just a number, sometimes it's a combo. So it's an x. So we take that x and we pull it out to the front. Really, guys, what we're doing is we're dividing both things by x. That's what's happening, okay? So what's left? Well, what happens when you take 7x squared divided by x? What's left? 7x. What about when you take 9x divided by x? What's left? Yep, so this factors into x parentheses 7x plus 9. So that's common factoring. You always want to check if something has a GCF first. That's always your first step. Okay, after that, we have binomial factoring. So let's say I asked you to factor something like this. This is probably what we spent the most time with in algebra, I think. So what happens with binomial factoring is we are reversing FOIL. Okay, what's the F stand for? Firsts. O and I stands for the outsides times the insides, or the outers times the inners, and then L stands for the last. Okay, what happens with this is I think we can figure out the firsts. What times what gives you an x squared? An x and an x. I think you can find out the lasts But the kicker is, can you figure out which lasts work with the middle term? Give me an example of something that multiplies to be 63. 7 and 9, okay? Right? There's other things. You could do like 3 and 21 if you wanted to. So 7 and 9, you want to do plus 7 plus 9? Okay. Watch what happens. This isn't right, by the way. I'm going to show you how you check. So my first work, my outsides and insides don't work though. What does this give you when you multiply those two? 9x. What does this give you? 7x. 9x plus 7x is positive 16x. But I need it to be negative. What should I do? Make them both negative. Isn't a negative times a negative also a positive? Okay, so this is where I tell students when you do factoring, you want to use a pencil. Or not, you just use a lot of paper. It's going to be x minus 7, x minus 9. Box that one so we realize that this one doesn't work. Okay. Kinda, sorta? Yay? Nay? Remember? Okay. Next time. What if I give you something and it has a number in front? So 2b squared plus 17b plus 21. Okay, now I am going to give you choices. Do you remember box method? Or not remember, do you remember seeing box method before? Some of you do. Oh, good. I never had box method when I was a kid. I just multiplied them and checked my answer. And eventually you're going to get the right one, okay? Let me show you how I did it before, and then I can show you box method, okay? So this is what I did before. I knew that this was a 2b and a b. How did I know that? Because I know that they have to multiply to be this. What are your choices for multiplying to be 21? 3 and 7 or 21 and 1, okay? So what I would do is, in my head, I would just check, is this a 3? Is this a 7? Is it a 7 and that a 3? Or is this a 1 and a 21? I would just check them all and check the outsides and insides to see which one worked, okay? Now what happened, you don't like that, huh? Well, here's what I like about it. If you can kind of do it, you can do the outsides and insides in your head and then pick the right one. Here's what I mean by that. Outsides, let's do this one. Hopefully, oh crap, did I get it right the first time? Look where my fingers are. If the 7 was here and the 3 was there, what would this give me? Multiply those. 14, what would that give me? 3, and 14 plus 3 is 17. None of these others would work. Like this one would give you 6 plus 7, which would be a 13. This one would give you 42 plus 1 would give you a 43. So that's how I did it. Okay? I'd use a pencil. This is what some students like to do. They didn't like box method. So now I will show you the alternative to that. Or this is what you can do. You are going to make a box. So this is just a different method. And your box is going to have 4 sections. You can cut your box like that. What you're going to do is you're going to take the first and the last thing and you're going to multiply them together. So what's 2 times 21? Shout it out. 2 times 21, 42. What you're then going to do is find the factors of 42 that add up to be 17. Can anybody do it? You need a calculator, you can get a calculator. Is it 7 and 6?
Yeah.
It's not 7 and 6. What's 7 plus 6? Yeah, so it's not 7 and 6. Let me know when you find it. Is he telling you? 3 and 14? Check it. What's 3 times 14? 42. Does 3 plus 14 add up to that? So you could start just taking 42 and dividing by things, is what I'm saying. You can do 42 divided by 2, 42 divided by 3, or 8. Find the factors. All right, so we agree that 14 and 3 works. So what we do is we put the 2b squared right here in that box. We put the 21 right here. In these two boxes, you put the 14 and the 3. Doesn't matter where. 14b plus 3b. Doesn't this box add up to be this? Yep. And then we take out the GCFs of each row and each column. So, what's the GCF of 14b and 21? 7. What's the GCF of 2b squared and 3b? Just 1b, yeah. So one of my factors is b plus 7. See that right there? Let's go up. What's the GCF of 2b squared and 14b? 2b. And what's the GCF of 3b and 21? 7. So my 3, right? 3 goes into 21 7 times. It's not a GCF. So my factors are 2b plus 3 and b plus 7. That's the same thing I arrived with my guess and check method. Same thing that I arrived with my guess and check. Okay, so we might need to practice that at sounding like, huh? So you're very quiet. I don't know why that is, if it's like you don't understand or you're tired. So I'm going to check. Would you grab a whiteboard, please?